Hi everyone, in this video we will learn how to fine-tune an open source large language model like Llama 3.2 in this case, using simple UI and just a few clicks, that too in your local personal computer. And stay till the end, because in the end I'll also tell you how you can access the code that we have developed and used to fine-tune the large language model. So without wasting any further time, let's dive in. Okay, so if I ask the Llama 3.2 before tuning, what is the price of gold membership in your gym? So this just says that I'm not aware of the information, which is valid because this is just the base instruction model. Now if I create a new chat and use the fine-tune model and ask the same question, now as you can see, it has now responded in a JSON output. That means I can use this model for function calling. It is giving me the tool name, operation ID, the tool parameter and everything. So using that I can do function calling. So this is what we are exactly going to do. We are going to fine tune the Llama 3.2. Then we'll create a purpose specific fine tune model. Okay, so let's proceed and start the actual tutorial. Okay, so now I have opened my IDE and let's start the absolute easiest way to fine tune any open source large language model. And as I have said, in this video, we are going to fine tune the Llama 3.2 3 billion parameter model using Unsloth. So if you are hearing Unsloth about first time, Unsloth actually helps you train a large language model faster, at least 2.5 times faster as they claim. And using Unsloth, training any large language model is easy. Even this is an open source project, so if you go to their open source repository, this has already got like 16,000 stars, so I'm sure many people actually use it. And as you can see, they are also supporting Llama 3.2. They have some notebooks, so if you want to use Google Colab notebook to fine tune the model, feel free to do so. But I'm going to do is actually going to use UI to do the fine tuning, because I believe most of us who are new to this AI space are not a data scientist or are not a really techie person to fine tune their model for their own business or for their own purpose. So that is what I have done. I've actually created this particular UI project that you can actually run it anywhere, even in your local system. And even in this case, I'm going to use my local PC to do the fine tuning. My PC have 12 GB of RTX 3060 graphics card. This is actually considered as very entry level graphics card. So if you have this graphics card or higher, then you would be able to do the fine tuning in your local environment for free. But if you do not have any graphics card or high memory or good CPU, that's fine, because in this video at the second part, I'll show you how you can leverage a GPU and do the fine tuning and export your model out, so that you can actually later on use the model in your local system or anywhere you want to use it. Okay, so very quickly, what you need to be able to run this code is you need a WSL environment. Why we need WSL is because there's a specific requirement of a library called Triton, which is not available on Windows. So as a result, I could not use the base Windows machine to do the fine tuning. That is why I had to use WSL, Windows subsystem for Linux. And again, same thing, all you have to do is just create a conda environment. Just use something like untrained Python 3.12 and just create the environment. I've already created the environment, so it will not work for me. So I'm just going to activate the environment. So this is activated. Now in the project, if you go to README and if you have NVIDIA GPU, what you need to do is you need to install Qt NN and you need to install CUDA as well. So please go through the README and install these two requirements. So I have also provided the link. You can actually just download, and it's just download, double click, click next and install. Okay, so it's not a very difficult step. I've already done that as well. So the other thing that you can do, if somehow installing the Qt and CUDA library doesn't work, is just install the Torch Vision, Torch Audio using this pip install command. I will keep this in the readme file, and then you install the Onslaught and everything, and then you run pip install -r requirement. So the requirement have everything. So what happens sometime is, although the requirements library are kept in order, what happens sometime I have seen is it's trying to, let's say, install and download a library like transformer library before the torch library, and as a result we get compilation error. So that is why I'm just kind of advising you to maybe run this separately if you're facing that issue. If you're not, just you can just directly do pip install -r requirement, and that will get every library installed that is required to run this program. Okay, and once this is all installed, what you have to do is just run python main.py. So everything is coded. I'm going to walk you through the code very briefly. I'm not going to go through very detail because, as I said, this is a dummy guide. This is a no-brainer kind of guide, so I don't want to go into very much detail on that. But yes, this code is available to you, so you are free to check the code and see where you can improve it, or you see where you want to understand it yourself. And if you have any question, come into the community and raise it there. Okay, now I'll just go there, and here this is how your UI will look like. So there are a couple of steps, as you can see: settings, dataset, training, test, GGUF conversion, and upload to Hugging Face. I'm going to go through each one of them step by step. So first thing what you need to do is come to Hugging Face. You need the Hugging Face token. So we'll go there, settings, and then access token, and we will create a new access token. We will name it Llama Finetune. So we name it Llama Finetune, and we use write access. Okay, why we need write? Because later after the fine tune, we want to upload our model, so that we can use it anywhere else, right? So that's why we want to use write, and just copy the token, use it there, like add the token here in the Hugging Face token input area. And in the model, you will see a couple of models. Just select the Llama 3.2 3 billion instruct. That is the latest model. We are not fine-tuning the vision model because Onslaught doesn't support the vision model yet, as I was showing you earlier. But if you want to know how to fine-tune vision model, let me know in the comment. I will bring another video. That's not a problem. Okay. So we'll just click load model, and you will see that if you're running it for the first time, you'll see that the model is getting downloaded, all the checkpoint file and everything is getting downloaded. So it will take few moments. So as you can see, the model is now loaded, and that's what you will get. So now once the model is loaded, now we move on to dataset. Now we need the dataset to fine tune. So here we will use our own dataset, but if you want to use any Hugging Face dataset, we have this Hugging Face option there as well. So you can either select local file or Hugging Face, and you specify the data path of the Hugging Face, dataset. And as you do that, it will just download it and it will prepare the dataset. Okay, we will use the local file dataset. So we'll just browse it and we use this sample dataset. Now let me show you quickly how the dataset looks like. So I come here, and this is the dataset. So the dataset is written in human and assistant format. So the human is like, I want to know the price of the silver membership, and the assistant is saying in this JSON output. Okay, so that's how we have defined this output. How we have done that? Previously, actually, I have created another video about the Naughty AI project where, if you are new to the channel, just to let you know, the Naughty AI is one of my open source project where I have tried to create a voice assistant. And in one of the video, I have also shown you how you can train an OpenAI models basically. And that is why I created a few dataset in JSON-L format. If you want to see how to, do the fine tuning of OpenAI models, I will attach the link of that video in this description and also on the right top, so you can see it from there. So this is what actually I have taken, and I have converted this in this format. Okay, so this is the exact data set that I have taken, which I have used for the OpenAI fine tuning. And then if you want to actually use your own datasets, feel free to create the dataset. Make sure it is in this same format. So you can use ChatGPT or Cloud or something. Just specify that you give your dataset and you just ask Cloud AI or OpenAI to convert the dataset into this format, and that will convert this for you. Okay, and then you save it. So the way I have written this code, it will accept JSON format or CSV format. So you can upload either of this format of dataset and then click prepare dataset. As you click prepare dataset, it will actually, under the hood, what it is doing is, if you go to the dataset utils, it is just using the Llama 3.2 tokenizer, and then it's kind of apply a chat template for that particular model. So whatever Llama 3.2 prompt template is, it will actually convert the dataset into that format. Okay, once the preparation is done, we can move to the next step. By the way, if you do not know how to create a dataset, let's say, and you want AI to create a synthetic dataset for you, I have also created this area where you can actually create the dataset with the help of AI. So here what you have to do, let's say in your application you are using few shot prompting, so you just give the example of the intended dataset or intended format. For example, in this case the intended format is, and this is my intended format, right? So if I just, let's say, take this, I'll just take this one just to show you an example. I'll put it here. This is my example conversation. This is how I want to, this is what I want LLM to respond in the format, and then the expected data structure is what Llama 3.2 expects. So this is the data structure that Llama 3.2 expect, right? So we can just copy that. Okay, we can copy that and we can come back to the UI and provide it the expected data structure. Now, how many sample that you want to create, you can select 100, 200, 10, 15, whatever, and then you select OpenAI, provide OpenAI API key. And once you click synthetic dataset, under the hood, it will call OpenAI API. It will provide the example intended output and the expected data set structure that the base model expect, and then it will actually create the synthetic dataset. Now this function may not work properly. I just want to be absolutely clear here that I haven't tested this functionality yet properly. I have only created one time using this synthetic dataset function. It worked properly, but I haven't tested it. We will continue to work on this one. So if you join the membership, I will definitely update it there, if not in a separate YouTube video. Okay, so if you can, please join the membership. That will help the channel as well. But yeah, I will update on this feature once this is ready on the membership post or as a separate video. Now in this case, the dataset is prepared. We will just go to training step, and here you can specify different training steps like your learning rate and your batch size, number of epochs and everything. Now for this example, I'm just going to do a very small number like 20 epochs, but generally you need large number of dataset and large number of epochs to fine tune a model properly. In this instance, I have approximately 30 examples. And now if you have more, that is better for fine tuning the model. And once you set the number epochs, I'll just do start training. Now as you click start training, you will see that the training has started. Now I'm not sure if how my GPU will react with the video recording on plus the tuning running on, but it will take approximately 5 to 10 minutes to complete the training. One of the most important part in the training is you should see the loss. The loss should be reduced, as the fine tuning will go on. As you can see, it is reducing in this case. The lower the number of loss, the better the fine tuning is. Okay, so make sure that the loss is actually getting reduced each and every fine tuning steps. I don't know how my video is coming with the training running on my poor GPU plus the video recording, but let's just give it some time. I think it will take another 1 minute to get it completed. I think the training is completed now, as you can see here. So we will now go and test this model, the fine-tuned model. So we'll come here and we will see what is price of gold membership, and we test the model. Now, as you can see, it has responded with the expected output. That's how we expected the model to respond after fine tuning. And generally why I need that is because I was doing function calling in my AI agent based on the LLM response. So that is why I wanted to fine tune the model to do function calling as there, and it seems to be working. So this is good, and you can actually train on your own data. For example, it has came up the product name as gold membership. Maybe in your case you do not want the product name to be gold membership but just gold. So that is how you train the model, so that it knows that what should be the product name or how should the product name be responded in the response. So it will respond accordingly. Okay, again, I've used a very small data set and small number of steps, but it was still working fine. I'm glad to see that. Now, once this is ready, now let's say this is tested using the fine-tuned model, but it needs this program, right? But let's say you want to use this model in Llama file or anywhere, like let's say in using any other framework like Llama or Light LM Studio or something, then you need a GGUF file. Or for example, you want to test it in your CPU machine, then you need a GGUF formatted file. For example, at the moment, if you see the output, you only have safe tensors file, right? So that's not ideal to use it with LM Studio and Llama. So for that, I have also specified another step which is called GGUF conversion. So you go to GGUF conversion and you need to specify a path. So I'll give it a path. Let's say I'll just name it naughty AI. Then let's say I name it this. So what it will do, it will actually just say dot slash. So basically it will create a folder and it will convert the fine-tuned model into a GGUF file and it will save it there. Okay, so I'll just click convert. And this conversion is actually going to take a lot of time, and my GPU is already loaded and the disk is already loaded. I'm seeing some warning. So I'm going to pause the video, and once the GGUF file is created or converted, I will resume the video then. Okay. But yeah, this will take some time, like 5 to 10 minutes of time to do the GGUF conversion. Okay, so the conversion is now completed. It took approximately 5 minutes, and you will be also able to see that here, but I don't know why it's showing an error here, but don't worry, I think I can see that the conversion is successful. I will check why the UI is throwing error, and I'll again update it in the member community. So if you go here, you will see this GGUF file. That means the GGUF file is created. Now you can test this GGUF file. So we will test it with Llama in the next step. But before I do that, let me quickly just complete the tutorial regarding this UI. So I have also now added another feature to upload the file to Hugging Face. For example, you are training your model or fine tuning your model in a cloud VM somewhere in a GPU rented VM, let's say. Then you definitely want to take out the fine tuned model, right? So that is why I have added this section to upload the file into the Hugging Face. Now you can upload both the core fine-tuned model, which is the safe tensor files, or the GGUF converted file. So if you click the GGUF one, you have to specify the path where the GGUF file is located. Or if you use the fine-tuned model, then you don't need to specify a path. The UI should know, or the program should know where the fine-tuned model is, because it has just done the fine-tuning. Okay, so we will select the converted model, and then we will go to the Hugging Face, and we go to models. We click here in the new model, and we name it, let's say, naughty AI tool model. Keep it public. You can keep it private, but I will say keep it public, because otherwise the write operation may not work. And all we need to do is just copy this path provided it here. So that is the repository name, and the GGUF file path is this path. So we will copy the relative path and paste it here. So now we have this, and we will just click upload to Hugging Face. I think it's because of the slash. Yeah, so I just need to change the slash. Now it knows where the GGUF file is, and shortly you should be able to see the upload has started. So again, it will take some time, depend on your internet connection. It will take few minutes to upload the entire model. Yeah, as you can see, it has started uploading the file, and it just uploaded 1%. So while it is uploading, let's also try to load this model into our Llama and test it. Okay, so for that, what we will do is we'll come here and we'll add a model file, and in the model file we'll just say from dot slash on sloth. Basically, you just need to copy the path from here. So just copy that. .gguf. Okay, so now we have just given that, so our model file is there. What we have to do is come back into our code space. We'll go to PowerShell and make sure our Llama is running. Yeah, our Llama is running. Go to the folder where our GGUF file is there, and we issue this command Llama create naughty v2 or v1, whatever name you want to give, that's not a problem, and specify the model file. And if we hit enter, this will actually load this model into the Llama memory so that we can actually test it. Okay, so this has added the model, so let's test it. So just like the last tutorial, we will open the Open Web UI using Pinocchio. Start it. Yeah, I think it's started now. So we'll click Open Web UI. And because this Web UI is using the Llama in our local, we should be able to see our model. So as you can see, v2 is loaded. So we'll just select that, and we will ask like let's say, help me book an appointment tomorrow at 12 p.m. And as you can see, it has responded in the format that we have fine-tuned the Llama 3.2. So that's great. It's working in the local. We have been able to do the fine tuning in the local. However, as I have said, if you do not have sufficient GPU to fine tune it in locally with this tool, what you can do is you can rent a cloud VM with GPU capability, and I would recommend you to use the massed compute. Now for massed compute, in my previous video also I have shared the registration link as well as a special coupon code which will reduce your rent cost straight 50%. So let's see if I use base and use like deploy, and we use A6000. I use Windows SSH key and use the coupon code Know Together Labs. So that will straight away reduce the price to 0.31. Okay, so just to show you again, generally otherwise it will cost you 0.62 per dollar. With our coupon code and the tracking link that if you use to register your account, you get 50% discount. So please make sure to use that, and rest of the process remains same. Just download the code, use the link from the video description, download the code, and do exactly the same steps that I have shown you. I'm not going to repeat the same thing, just that will lengthen the video unnecessarily. However, if you face issue running it in the massed compute VM or anywhere, let me know in the community, raise an issue or something, and if you take a membership, I will update you on different features that I have not tested yet on this application. For example, the dataset creation, synthetic dataset creation, and loading the Hugging Face. I haven't tested all of it yet, but yeah, I will update you onto the membership. So please consider taking the membership. That will also help the channel. And with that, I'm going to end this video. If you want to actually see how to use Llama 3.2, click this video to see how to use Llama 3.2 locally and in your cloud VM with even the vision model. And if you want to see how to create this kind of application using Cloud AI, I have actually created this application using Cloud AI. And if you want to learn how to create such application using Cloud AI, click this video where I have described the entire process. Okay, so please take care and I'll see you in the next one.